Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Professor, Editor-in-Chief, and other reviewers. It's an honor for me to have the opportunity to present our research titled Effective Methods for Employee Performance Assessment. My name is Agatha Himawan, and I will be sharing the key aspect of this research. The topic I will cover in this presentation include the introduction, methods, issue and discussion, conclusion, and reference. The main challenge in employee performance appraisal include variation in workload and the need for the criteria that accurately reflect diverse performance aspects. To address that issue, multi-criteria decision-making (MCDM) methods are used, allowing organizations to assess both quantitative and qualitative factors simultaneously. A comparative experiment approach is employed to evaluate the effectiveness of different MCDM techniques, such as SAW, AHP, and TOPSIS, under similar conditions, highlighting their strengths and weaknesses. To ensure reliable and valid results, statistical tests like ANOVA are conducted to compare the performance of these methods, providing insight into the most suitable MCDM approach for enhancing employee performance evaluation. This article focuses on comparative experiment approach by comparing the SAW, AHP, and TOPSIS methods to determine the effectiveness and relevance of the methods applied in an employee performance appraisal system. The study aims to provide insight into MCDM methods that can be implemented to enhance performance appraisal system in organizational environments. The research methodology used in this study involved a comparative experiment approach divided into 4 stages: variable identification, data collecting, data analysis, and testing. The SAW methods find the best alternative of all alternative evaluation indicates. The best concept of the SAW methods is to find the weighted sum of the performance ranking for each option. The SAW methods require normalizing the decision metric to scale that can be compared with all other alternative orders. The SAW methods has several stages: analysis, normalization, and ranking. At the analysis stage, first determine the criteria and alternative needed. The requirements are divided into benefits and costs. In the normalization stage, the attribute values will be converted into number value from 0 to 1. RAZ equal XIG divided by max XIG if Z is benefit, but if G is cost, or IG equals min I XIG divided by XIG, where IG denotes normalized performance rating value and XIG denotes criteria attribute value. The next step is to carry out the ranking stage by using the Sorong formula shown as follows, where RIZ denotes normalized performance rating value and XIG denotes criteria attribute value. The next step is to carry out the ranking stage by using the Sorong formula shown as follows. V is frequent value, W is ranking weak, and IZ is normalized performance ranking. The AHP method is a decision support model describing the multi-attribute decision-making problem, or MEADM problem. AHP is used to solve a problem in a systematic thinking framework so that effective decision can be made. The step in performing the AHP methods can be seen in the table 1. The TOPSIS method is a method that can be used to solve problems in decision making. This method has a concept where the chosen alternative is the best alternative that has the shortest distance from the positive ideal solution, a place of plus, and the farthest distant from the negative perfect solution or aiming. The steps in using the TOPSIS methods are 1. Determining the weighting criteria. 2. Determining the value of each alternative. And 3. Making a normalized decision matrix. 4. Making weight on the normalization decision matrix using the formula. And then 5. Determining the value of positive and negative ideal solution using the formula. And the 6. Determining the distance between a values alternative with the perfect solution matrix and determine the preference value for each option using the formula. The data used in the study are scored from STP, employee performance target, work behavior values, and criteria data. See the forthcoming table 3. The Global Atmospheric Monitoring Station in Sorong has 16 functional employees, whose performance assessment will be carried out. See the table 2 for the detail of the employee. The table 2 contains the employee data used as the dataset for calculation in the three MCDI methods. The employee data include the employee name, position, rank, and length of the service. Table 3 shows the weight of each criterion based on the 2019 government regulation. The criteria for assessing employee performance are service, accountability, competence, harmony, loyalty, adaptability, collaboration, and employee work goals. The assessment parameters for each criterion are different. Table 4 shows the assessment parameter for the service criteria, harmonious, loyal, adaptive, collaborative, and STP. Table 5 shows the assessment parameter for the accountable standards. Table 6 shows the assessment parameter for the competence criteria. And the table 7 shows the calculation result of the STP score for each employee. The Global Atmosphere Monitoring Station in Sorong has 16 functional employees whose performance assessment will carry out. The performance evaluation is based on STP values and employee work behavior values. The employee performance is calculated by using the formula as follows. Employee performance is SKP value multiplying 0.6 plus work behavior values, whereas this SKP assessment is calculated by using the formula as follows. SKP is realization divided by the target multiplying 100. The data analysis employed in the study involve examining and interpreting the college data to identify difference and similarities between the methods being evaluated. In the context of a comparative study of MCDM technique, the data analysis include applying each method to same data set. In the SAL methods calculation, first step is to group the existing criteria into two types of attribute, benefit and cost. The distribution of characteristics on each criterion is shown in the table 8. Meanwhile, the employer personal data and the normalized data are shown in the table 9 and 10. After normalizing employee data, the ranking process is carried out. The preference value is obtained by multiplying each criterion weight with the normalization value. Then, a weighted summation of all criteria is performed. The ranking results can be seen in the table 11. Of the 16 employees at the PAG Sorong station, it was found that 15 employees ranked first with a preference value of 0.98224. The second rank was occupied by P14 employee with a reference value of 0.980874, and the third rank was occupied by P2 employee with the preference value 0.97813. Calculation using the AHP methods in the employee performance assessment system require to determine the resulting comparison from the three techniques. In the AHP method, the first step is determine the comparison metric between a criteria. The criteria comparison matrix can be seen in the table 12 and the calculation ratio of priority seen in the table 13. Obtaining an alternative ranking requires the consistent index value atau or CI, the index ratio value RI, and the consistency ratio value atau or CR. If the CR value ranges from 0 to 0.1, then theoretical consistency is acceptable. But if the CR value is more than than 0.1, then it is considered inconsistent. The CR value in this calculation is 0.0120, which means that the consistency of the hierarchy is acceptable. The alternative ranking is done to find the highest score based on the employee performance operational system. After obtaining the alternative value, the last step is to determine the alternative ranking result by multiplying the value of each criterion against its priority value of the criteria matrix. The result can be seen in the table 14. The first rank was obtained by 6 employees with the same preference value of 0.2837. P11 employees received the lowest score with a preference value of 0.2350. Calculation using the TOPSIS method in the performance assessment system are carried out to determine which way has the accuracy and precision of use in the solving problems. In the TOPSIS methods, and the first step is to determine the weight criteria and determine the value of each alternative. After selecting the requirement and the value of each option, then create a normalized decision metric which can be seen in the table 15. The next step is to create a weighted normalized decision metric by multiplying each alternative normalized decision metric against the weight of each criterion. The results can be seen in the table 16. The next step is determining the distance between the alternative value and the ideal solution metric shown in the table 17 to 18. The last step is to determine the preference value or ranking in the table 19. ANOVA testing is used to determine whether there are statistically significant differences between the methods being evaluated. By analyzing the variance among multiple groups, ANOVA helps identify if the difference in the outcome are due to the specific method applied rather than random chance. In the context of comparing MCDM techniques, a one-way ANOVA test can assess whether a method like a Sorong, AHP, and TOPSIS produce significantly different results when applied to the same dataset. This statistical test is crucial for validating the effectiveness and the reliability of each method under the same condition, ensuring that conclusions drawn from the comparative study are robust and accurate. The formula for the one-way ANOVA test is primarily based on partitioning the total variance into between group variance and the within group variance. The formula calculates the F ratio, which is the ratio of these two friend the variance to determine if the means of different groups are significantly different. The formula is stated as follows: P is ms between divided by ms between, where f is the ANOVA static value, ms between is the mean square between group, and ms between is the mean square between group. The criteria is shown in the table 12, 20. Alpha test criteria is 5%, p-value 0.05. There is a significant difference, or no difference for p-value is 0.05. The comparison between the simple additive weighting is how analytical hierarchy process AHP and the technique for order of preference by similarity to ideal solution TOPSIS methods was conducted using the same dataset within the context of an employee performance appraisal system. The dataset includes criteria such as service, accountability, competence, alignment, loyalty, adaptability, collaboration, and achievement of a target. The comparison result between the SAO, AHP, and the TOPSIS method in the employee performance assessment can be seen in the chart 1. In the chart 1, it can be seen that the best employee based on calculation using the SAO method was given to P15, who ranked first with a value rank of 0.98222. Different results were obtained when calculating employee performance assessment using the AHP methods. The first rank is given to employee P1, P2, P13, P14, P15, and P16 because they have the same value. Here, the chart 1, the comparison is show AHP and the TOPSIS set of reference value. In the TOPSIS method, employee P14 ranked first with a reference value of 0.91368, differing from the SAO method with a rank P15 as the top employee. Despite this, P15 outperformed P14 in work behavior, having 100% attendance compared to P14 95%, and held a position with a greater workload and longer hours as the field observation coordinator. The SAO method provided to be the most effective and relevant for evaluating employee performance, showing high accuracy by directly erasing weight a score for each criterion. This method provides a clear and consistent ranking system that reflected difference in workload and responsibilities, with a reference value closely matching the dataset. So, straightforward calculation process made it a practical choice for organizational use, facilitating a quick evaluation with minimal complexity. In contrast, the AHP method was less precise due to its fairways comparison and complex complex weighting. It sometimes gives equal rank to employee despite difference in workload, reducing its effectiveness in the differentiating performance level. ESP also require more time and subjective input, leading to the potential biases. While the TOPS method was helpful for visual gap analysis, it did not accurately represent workload and responsibilities in the dataset, leading to potentially misleading results. Its sensitivity to criteria weighting made the consistency difficult, and the complexity of its calculation increased the risk of error compared to the simpler SAO methods. The test significant difference between the three MCDI methods, SAO, EHP, and TOPSIS, and generalizing ranking, a statistical analysis was conducted using one-way ANOVA. The ANOVA analysis was used to determine if there were significant difference in the average score produced by the three methods. In the figure 2, the ANOVA test indicates the there were a significant difference between the ranking score produced by South compared to ESP and the TOPSIS. The p-value obtained was below the significant level of 0.05, indicating that the results from the three methods are not statistically similar. This result strengthened the finding that the SAO methods provide more accurate and consistent performance evaluation, aligning well with the characteristic of dataset use. In contrast, the HP and the TOPSIS methods produce a ranking that were less suitable for capturing individual employee performance noise. In the conclusion, the comparative analysis showed that the SAO method is the most effective and relevant for the performance appraisal system in the case study. It accurately calculates a preference value, providing clear ranking that reflects each employee performance. The simplicity and the transparency of SAO make it ideal for inference needing a quick, objective, and reliable evaluation. So its consistent result with a minimal bias make it the preferred choice for alignment performance score with organizational goals. Organizations aiming to improve their appraisal system should consider SAR, especially for complex datasets that require clear performance differentiation. Also, ESP and topics offer useful insight in the certain context. The complexity can make them less suitable for straightforward evaluation. The study confirmed that shall provide a more reliable and effective approach for employee performance appraisal, balancing a query, ease of use, and alignment with organizational needs. Another test result also support South is superiority in this context. Future research called uh, future research could explore additional parameters for ranking, including a 5G criteria and a method like a 5G aggregation for a more nuanced assessment. Here are some of the reference used in the research. And that concludes my presentation. Thank you for your attention.